writing formulas.
Today we're going to show you how to write formulas for simple ions, multivalent and polyatomic ions, covalent ions, acids, and hydrates.
So the first thing we're going to learn about is simple ions. And we're going to use calcium and chlorine to help us. My nifty sissy Sydney is going to help me. So I will be calcium.
I will be chlorine.
And these are our charges. So when you want to write the formula for two elements, all you do is you write the charges above and then you switch them.
Like crisscross applesauce.
But you don't want to have a 1, you just want to assume the 1 is there. So this would be the formula, CaCl2. As we just showed you with calcium and chlorine, we ended up with CaCl2. How about if you want to write it? You would go calcium, and you would write chlorine, but you drop an ending for an IE ending. And you would end up with calcium chloride.
So now I'm going to teach you how to write a formula for multivalent and polyatomic ions. So here we have gold and sulfate. Gold is the multivalent ion because, as you can see, it can have a charge of +1 or +3. And sulfate has a charge of -2. So for this example, I'm going to be gold with a charge of +3. And Shayleen is going to be sulfate with a charge of -2. So what you do is the same as the simple ions, you just cross the charges. So now you have Au2SO4-3. But as you can see with the polyatomic, it's got the number 4 there plus the -3, but you can't have that. So you just add brackets and you're good. Now that we have the formula for gold sulfate, we can change it to the written form. So all you do is you write gold, and because that was the multivalent, you need to state what charge it was, which was 3, so you use Roman numerals to do so.
Don't tell me your stuff. Actually, yeah, that is wrong.
And with the polyatomic, with sulfate, you do not need to change the ending because it's already changed for you. So you keep it at sulfate. So you have gold, 3 sulfate.
We're going to talk about covalent ions. Now for covalent ions, you use the elements on this side of the staircase. So we're going to use nitrogen and oxygen. Now, to write them, you do your switcheroo thing again. So you come up with N2O3. But to go backwards, you don't want to write it like this. You want to use these beginnings. So that nitrogen has 2, you're going to use the di. So it would become dinitrogen. And since oxygen has 3, you're going to use tri. So it becomes dinitrogen trioxide. And remember to change your ending to oxide.
Now we're going to teach you how to write acids. You can identify an acid from the formula if it has hydrogen in front of it. So when you write a simple acid, the H turns into hydro. And for chlorine, you change the ending to ic. So it becomes chloride. And because it's an acid, you just add acid at the end. When you're writing a polyatomic acid and it ends in 8, so like hydrogen nitrate, the ending changes to ic. But because it's a polyatomic, you don't write the hydro in front. So it just becomes nitric acid. And when you have a polyatomic ion that ends in ite, you change the ending to us. So you drop the hydro and it becomes nitrous acid.
So last thing, we're going to talk about hydrates. So just like we did with our multivalent and polyatomic ions, we're going to write this in our formula form. So you're using iron 3. So this is what iron 3 phosphate looks like in formula form. But as you see at the ending, we have this octahydrate. Now hydrate simply just means water, so H2O. But that has the octet in front of it, so that's going to mean 8. You turn into iron phosphate octahydrate. But you're going to either need to put a dot or an X here. So that is the simple formula for iron 3-phosphate octahydrate. FePO4.8H2O. Now, if you want to go the opposite way, you just would write it just like you did. So FePO4 would turn into iron 3-phosphate, and then, like I said, hydrate just means H2O. Well, there's an 8 in front of it, so it becomes octahydrate. You guys learned something?